A very good day to you all. Today I will be discussing ratios, and here are the highlights of some subtopics that we shall be discussing under this topic. The first one is we're going to define ratios. Second, we're going to talk about the way and different forms of writing ratios. We also review equivalent ratios. We talk about simple problems on ratios, and lastly we talk about how do we share quantities in a particular ratio. The first one, which is the definition of ratios. Ratios is a way of comparing two or more certain quantities. Whenever we need to compare two or more certain quantities, we use ratio. Or better still, we can define ratio as a way to express the relative amount of a certain quantity with respect to another quantity. So in a nutshell, we can say a ratio is a proportion. A ratio is quite a proportion. So in two ways down, in a summary form, we can say a ratio is a way of comparing two or more quantities. Or we say that ratios is a way to express the relative amount of a certain quantity with respect to another quantity. The second way, or the second subtopic that we shall be discussing today, is how we write ratios. There are three forms or three ways by which ratios can be written. The first way by which we can write ratio is in the word form. The word form. And this is writing with the usage of to, putting to in between the two comparing values. For instance, let's say we have 5. So we have 5 to 6. This actually is talking about 5:6. It reads as 5, the ratio of 5 to 6. This is the first way by which you can write a ratio. The second way by which ratios can be written is in column form. You can write a ratio in column form, and that is by putting a column between the two quantities that we are comparing. Just like the first one I made mention, if you want to write this first one in the column form, now we write it as 5 column 6. 5 column 6. And don't forget, this is read as the ratio of 5 to 6. It reads as the ratio of 5 to 6. 5 colon 6. The third way by which ratios can be written is when we write it in fractional form. Don't forget, a fraction is also a ratio. A fraction is also a ratio. So if you write a ratio in fractional form, then we have something like this expression I've just mentioned. We write 5/6. This actually means 5:6. That means the first number goes to the numerator of the fraction, while the second number goes to the denominator of the fraction. So in a nutshell, we have three ways to express ratios in a summary. The word form, which is writing by the usage of to between the two numbers. The second form, that is by having a column between the two numbers. And the third form, that is by having fraction, writing them in a fractional way. And we call it tax 1. Tax 1, the first task is that you write 3 to 4. Write 3 to 4. That's a ratio. In ratios, in another two other ways. We know we have 3 other ways of writing ratio. So this one way. We have 2 other ways. Write this particular one in 2 other ways that I've just explained. Now I want to explain the fact that ratio is a comparison. We have to get that very clear, that a ratio is a comparison. For instance, let's say if you have 2 dogs and 3 cats, we can compare them using ratio. If you have 2 dogs and 3 cats, we can compare them using ratios. And how do we do that? We can say that you have a 2 to 3 ratios of dogs to cats. That is, to every 3 cats. To every 3 cats. That is, that we have 2 dogs and 3 cats. Or we can say that 2 to 3. The ratio of the dogs to the cats is 2 to 3. Or you say 2 column 3. Now, another way is that if we have this example, let's say we have the parking lot has 5 cars. For every 2 trucks, write this as a ratio. That's a question. The parking lot has 5 cars. For every 2 trucks, write this as a ratio. Now, what are they saying here? The first one is they are mentioning cars, and the second one is the trucks. That means we have cars and we have trucks. We have trucks. Now, you can see that the first one goes to the first, that is the first ratio. The parking lot has 5 cars. That we have 5 cars, and the trucks for every 2 trucks. That means the second particular number goes to the second parameter they are talking about. So we can say that the ratio of cars to that of the trucks is 5 to 2, or we can say 5 column 2, or you can say it's 5 over 2. That is the ratio of the cars to the trucks. In most cases, some people don't always pay attention to the way the questions are written. You always follow how the questions is being asked, and please always write in the order of the way problems appears. If the question were to say that this is we should find the ratio of the trucks to the car in this above question, if the question was to say we should have the ratio of the trucks to the car, that means we are going to be having something like 2 ratio 5. That is trucks to the car. Or we have 2 column 5, or we have 2 over 5. So it's just because the question say cars to the truck. That's why we have the other one at the left. Let's have this as well. Let's have this as well as an example. Yeah, the question says A plus schools JS2 has 5 girls and 7 boys. What is the ratio of girls to total number of the students? What is the ratio of girls to total number of the students? In this question, if the question says what is the ratio of girls to boys, you could have said that this is 5 ratio 7 based on the question, because they say 5 boys and 5 girls and 7 boys. So the ratio of girls to boys will be 5 to 7, and that is not exactly what we are asked to find. And that is why I said questions should be taken or read carefully. We are looking for the ratio of the girls to the total number of the students. Actually, that is girls. We are looking for ratio of girls to the students. To the students. Now, the girls has already been given as 5, but the students is actually 5 plus 7. That is total number of the students based on what we have. Yes, and that actually give us 12. So the ratio of the girls to the students will now be 5, which stands for that of the girls, ratio 12, or you say it is 5 over 12. Better still, you can say 5 to 12. So the question exactly said 5 guys, to the not to the number of students. So please look carefully, read carefully the question and follow the order at which the question is being asked. Very shortly, I will be talking about equivalent fraction. And remember, I told you that ratios is also same as fractions. They are synonymous. And another way of writing ratios is fraction. I told you it's one of the methods of writing ratios. So if you have been taught or if you have read anything about equivalent fractions, I must tell you, trust me, there's nothing new between the equivalent fraction and the equivalent ratio, since a ratio is a fraction. For instance, if we are being given 7, ratio of 7 to 14. Now, this is the same thing as 7 ratio 14. 7 ratio 14. Thereafter, now if I want to have an equivalent of any fraction, what I do is that I multiply that fraction either by a number. I multiply the denominator and the numerator of that fraction by the same number. Whatever I do to the denominator at the same time I do it to the denominator, it does not change the property of the fraction and that of the ratio as well. So by the time I divide or multiply that particular fraction or ratio by same quantity of same value, it does not change the property, and that's exactly what we call the equivalence ratio. Look at this ratio now. If I divide these two ratios by 7 ratio 14, if I divide this one by 7, this one by 7, I'll be having a ratio equivalent to 1 to 2. I can now say 1 ratio 2 is an equivalent fraction to 7 ratio 14. They are equivalent. They are equivalent. So equivalent fraction is gotten when you multiply or divide both the top and the bottom of a fraction by the same number. When you multiply both the top and the bottom by the same number in a fraction, what you get is equivalent fraction. For instance, if I have, let's say I have a fraction 2 to 3, I can say if I multiply these 2 to 3 by same quantity, let's say I multiply them by 2, this I get 4 to 6. That is from 2 by, this is from 2 by 2 and this is from 3 by 2. So I can say 4 ratio 6 is an equivalent fraction to 2 ratio 3. Since I multiply both ratios by same quantity, it does not change the properties. If I multiply them by 3, I will be having 6 ratio 9. That is from 2 to 3 by 3, and from that is 6 and 3 by 3, which is 9. So 6 ratio 9 is also an equivalent fraction to 2 ratio 3. So whenever I divide or multiply a particular fraction by same number, once I do it to both denominator and numerator, it does not change the property of the fraction or ratio, and that is what we call equivalent ratio. That's about that. Now, unit ratio, or we can say unit rate. We can be asked to find a unit ratio, and I must tell you, a unit ratio is, or a unit rate is a way of, another way, or let me say it's more or less an equivalent ratio or equivalent rate. And what does that mean? A unit ratio or a unit rate is a ratio that has a denominator of 1. A denominator of 1. And it is, I said it is a special type of equivalent fraction. So whenever we have a ratio that have the denominator to be 1, that particular ratio is a unit rate or a unit ratio. An example of that, look at this, 5 over 1. This is example, an example. 9 ratio 1. All these are unit rate or unit ratio. 3 to 1. All these 3 examples are examples of a unit ratio. In most cases, we find it in some problems. We can say 2 miles per hour. Look at that, 2 miles per hour. That is 2 miles per 1 hour. That is a 2 ratio of the miles to the hour is 2 to 1. In most cases, we use it to express quantities, basically in physical sciences. So if you are asked to make a ratio in a unit rate, all what is being asked of you is to make the denominator as 1. That does it. Make the denominator as 1. Now let's look at a typical example about this. Let's say the question says write this ratio as a unit rate, and they give us 15:3. We want to write this ratio as a unit rate. What do we do? We now look at what do we do to make the denominator 1. If you look at this is more or less 15/3, and the denominator is 3 here. How do we make the denominator 1? Divide both the numerator and the denominator by 3. So that give us 5 divided by 3 divided by 3 divided by 3. This actually gives us 5/1. So this is a unit ratio. You know why? A unit rate or a unit, because the denominator is actually 1. Are we together? Yes, I want to believe that. Now let's quickly look at another question. And the question says the ratio of boys to girls in a class is 8:7. If there are 40 boys in a class, how many girls are there in a class? The ratio of boys to girls in a class is 8:7. If there are 40 boys, how many girls are there in a class? What you firstly do here is that you set a proportion. The proportion of boys, we have girls, proportion of that. Then they say the ratios of boys to girls is 8:7. That just, but they don't say if there are 40 boys. So I will say this is 40 boys. They now say you should look for the number of the girls. Let that one be X. So let's now start a proportion. This 8/40 equals to 7/x. By the time I have that, I have equals to sign. You now equate the 2. By the time you equate the 2, what do we have? We now do, then we close this. That we close this. And when we close that, the first one, that is 8x equals to 40/7. And thereafter, this is x equals to 40/7, everything over 8. And by the time I cut this is 5 by x, that is 35. Actually, that means that there are 35 girls in that same class, whereas we have 40 boys. Then let's look at another method that can be used to solve this. We can use another method to solve this. And what is the other method? Then we were given the boys to girls to be this, to be 8:7. So we just write 8:7 of the boys. You now equate it to what do you have? They said number of boys is 40, but number of girls is what you are going to. So you now say 40 ratio. You let that one be x. So you now look at this. You look at this. How do we make 8 to be 40? That is, we multiply it by 5. Then, if for us to make 8 to the 40 multiplied by 5, that means to make 7 to be x, we also multiply it by 5. So thereafter, we then have this will be 40 to 35 will be equals to 40 to x. Thereafter, our x is 35. That's another method by which we can use to solve the question. Very well. Now, the second task is what I want to have a look at now. Let me give you another task here. And the task reads, Karim can make, that's first one, 14 cakes in 16 hours. How many cakes can she make in 15 hours? Karim can make 14 cakes in 6 hours. How many cakes can she make in 15 hours? Second question. The length and width of a small rectangle is 9 centimeter and 8 centimeter respectively. That's the length and the width. The length of the large rectangle is 24 meters. If the length and width of the two rectangles have the same ratio, what is the width of the large rectangle? That's the second question. Then let's move to another subtopic here, which says how do we divide or share a particular quantity into ratios? How do we share or divide certain quantity into ratio? I will be talking in two ways. The first one, when we want to share a particular quantity into two parts, how do we do that? And the second one is how do we share that quantity into three parts? Let's look at this. If a certain quantity Q is divided into two parts in the ratio A to B, a certain quantity Q is divided into two parts in the ratio A to B, what is the first part? The first part, if the certain quantity Q is divided into two parts in the ratio A to B, the first part will be A, don't forget we have A to B, over the total number of the ratio, that is A plus B, multiplied by what are they sharing? Q. That's the first part. Excuse me for this. That's the first part. Now the second part, don't forget the second part ratio is B. So the second part would be B divided by the total number of the ratio multiplied by whatever they are sharing. So the first part is actually the first ratio over total number of the ratio multiplied by what they are sharing, Q. And the second part is B, that is the second ratio, divided by A plus B, which is the total numbers of the ratio, the sum, multiplied by Q, which they are sharing. Let's look at this question together. The question says, divide 35 oranges between Olu and Ade. Divide 35 oranges between Olu and Ade in the ratio 2:5 respectively. Excuse me. This means that Olu has a ratio of 2. So Olu has a ratio of 2 and Ade has a ratio of 5. We now have to divide 35. Actually, there are 35 oranges we want to share between the two of them. The first thing is, what is total ratio? What is total ratio? The total ratio is actually 2 plus 5, which is 7. Then let's now look at the share of these people, that is the Ade, Olu and Ade. If the total ratio is that, then what is Olu's share? Olu's share, excuse me, Olu's share now, the Olu share will actually be ratio of Olu, that will be 2, over total number of the ratio, that will be 7, times whatever they are sharing, times what they are sharing is 35 oranges. So this is actually 5, 7, 35, 5 by 2, this is 10 oranges. 10 oranges. That is Olu's share. Now, what of Ade's share? Ade's share. For Ade, we have the ratio of Ade to be 5. So Ade has 5 over total number of the ratio, that will be 2 plus 5, which is 7, multiplied by whatever they are sharing. So 7 here, 7 35 5. So this is 25 oranges. So that means Olu has 10 oranges and Ade has 25 oranges. If you add the number of the oranges shared between the two of them, 25 plus 10, it actually gives us 35 oranges, which was the total number of oranges that they were sharing. Now let's talk about the case when we have 3 parts. If a quantity P is divided into 3 parts in the ratio A to B to C, the first part we have A over total number times P, whatever they are sharing. That's the first part. The second part we have B, that is B is the ratio of the second part over total number of the ratio multiplied by P. P is what they are sharing. And the third part is C over total number of the ratio multiplied by whatever they are sharing. So if they are going to share into 3 parts, that's actually the order by which they will be sharing. Very well. I want to explain something here, and I have explained this same thing during the equivalent fractions. If we have K is a real number, at the same time the K is non-zero number. If you have a ratio A to B, it will be also equals to ratio Ka to Kb, which means if you are multiplying a ratio by any same value, it does not change the property of that ratio. And I told you also, well, whenever you divide a ratio by any same value, it does not change the property of that ratio. Very well. Now I want to lastly talk about something here before I solve 1 or 2 examples, and that is about the fact that whenever if A over B equals to M and A over C equals to N, this means if A ratio B is M and A ratio C is N, then B ratio C is this. Look at this. B ratio C is this. I can write my B ratio C as B ratio A times A ratio C. Look at this. Actually, this can also stay cut out so that I have B over C, B over C, B over C. The right and the left are this the same. So I can write my B over C as B over A multiplied by A over C, which actually means B over A, according to what I have here, this is A over B. A over B is M, and that means B over A will be 1 over M multiplied by A over C. My A over C is N from here, so this is N. So this actually be N over M. You see the application of this in this example that I want to solve. The example says, given that A ratio B equals to 1 ratio 3 and B ratio C equals to 2 ratio 3. The question say, what is A ratio B ratio C? They say A ratio B equals to 1 ratio 3 and B ratio C equals to 2 ratio 3. The question says, what is A ratio B ratio C? Using the idea of what I told you, A over B is the same thing as A ratio 3. So I can say A ratio B equals to A 1 over 3 and B ratio C is 2 over 3. Let me write that one. I can say A ratio B is 1 over 3 and B ratio C is 2 over 3. That's well understood. Then I can say A over C, just like I want to write the way I wrote it. I can say A over C equals to A over B multiplied by B over C. So that B over C. I think yes, that's right. So that when I cut this, it gives me over C back, which is from the left. And don't forget my A over C. I want to look, A over C means A ratio C. So that means I want to find A over, and I will be given rather A over B, which is A ratio B, to be 1 over 3. So this is actually 1 over 3. B ratio C has been given to be 2 over 3. So that will be 2 over 3. So this actually gives us 2 over 9. So that means we can say A ratio C is 2 over 9. A ratio C is 2 over 9. So we have A ratio C equals to 2 over 9. So since we can also write A ratio B, and don't forget we say A ratio B is also 2 ratio 6. Since we have our A here and here, both are the same. So I can say A ratio B ratio C is equals to 2 ratio 6 ratio 9, which is the answer to that question. Another example, increase 44 rather in the ratio 2 to 5. We are increasing 44 in the ratio 2 to 5. We let the number be x, so that we have 44 ratio x is 2 ratio 5. That's about that. So I can now write this in a fraction, just that we know that a ratio is a fraction, 2 over 5. So by the time I do the cross multiplication, I have 2x equals to 5 by 44. And our x becomes 5 by 44 over 2. So this is actually 22. Our x then becomes 110. That is the ratio. So if you increase 45 in the ratio 2 to 5, it actually gives you 110. Now the last example that I want to give here is in this question, and this question is mostly asked in UTME questions, YA question. Even in the recent years, we have these questions or similar questions like this is always asked in between number 1 to 10 of every objective questions. What is the question? The question is, if A ratio B is 1 to 3, evaluate 4A minus B over A plus B. We are told A ratio B is 1 to 3. We want to evaluate 4A minus B over A plus B. What I'm going to do here is that I write these two in fraction. I write the ratio given in fraction. How do I write that? That is A over B is equals to, that is, or A ratio B equals to 1 over 3. And then I can say B ratio A, which is B over A, would be 3 over 1. So I now come to the question, which is 4A minus B. Since my B over A is 3, I can come here and divide every expression here, everything here, by A, so that I have 4A over A minus B over A. I wanted to even get B over A, just like I can now substitute this 3 straight over A over A. Don't forget, whatever you do to the denominator, you do it to the denominator. So that's about that. So by the time I have this actually be 4 minus B over A, everything over 1 plus B over A. Don't forget, B over A is actually 3 from here. B over A is actually 3 from here. So that we can now say that this is 4 minus 3 over 1 plus 3. So this actually will be 1 over 4. That's the answer there. Some other smarter ways is by substituting A equals 1 and b equals to 3 in the expression, you are going to still get the 1 over 4. Putting a to be 1 equivalent, you try to pick the equivalent numbers, and b to be 3 in the fraction given 4a minus b, you get the same answer. I want to believe you are blessed with the explanations I've made on fractions. And if there's any other question, you can forward your questions to me, and I will put my numbers at the end of the video. And there's another task I call task 3, which are of 3 questions that I would like you to practice. The 3 tasks will be shown after this video. The first one is is to test your knowledge on whatever that has been taught so far. Thank you very much. Your tutor has been Taylor Stephen Adebayo of A Plus Model Schools, Ikpetumudu, Osun State in Nigeria. Thank you very much and God bless. See you in our next class. Two dogs